I have slowly trying to convert SpritePad, so everybody knows SpritePad, to work with Commander X16. So I've done a bit of work, but it's slow going because I don't know TypeScript. So I'm having to learn TypeScript as we go. But I have progress. So here we go. So let it compile. There we go. Hit it, and again. I don't know why I have to hit it twice. So I've defaulted it to 32 bits in width, yeah, because the way I envisage it is that you'll be in Sprite, we'll be able to change the dimensions of it and stuff. But I have got it to show the individual colours that you put on, like so, and that's taken me a week to figure this out. A week.
It's really simple. There's a U in it.
There's a U. Yeah. Yeah. But it does work, and I've done quite a bit. Hang on. I need to make sure that the colours are right compared to the 16, so I need to look at the palette. But they all go on, and it represents in both the editor, the previewer, and the list. But the other thing is the overlay works as well. There you go. And it's in colour. So I have done quite a bit. It just doesn't look a lot. So yeah. So we've got it to show the colours. To do the overlay. Next target was to do a save. So what I'm thinking of doing is, I'm going to try and do Acme. I'll try and do Acme. I've got to understand how he's done it. But I'm definitely going to be doing Kick-Ass Hex. So convert to Kick-Ass Hex Assembly. Also, SpritePad's not going to be in there, so I'll take that out. And I'll create a new version of the SpriteMate format that is in there. So, yeah. It's no support for CPS. Won't be able to support CPS because the sprites are defined differently. That's why I've had to. It's taken me all this time to make this represent each colour, because it was written that whatever was in this colour, this sprite went to. Yeah. Now it doesn't. It represent whatever colour you're on. So I've had to change all the internal mechanics, because all that was stored internally was 0, 1, 2, 3, yeah, which was transparent, sprite colour, multicolour 1, multicolour 2. But because the advent of 16 colours, 256 colours, 4 colours, and when we do the characters, 2 colours. I'm not too sure. Is 2 colours on a sprite as well?
No.
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 I didn't think so.
Sprites are only 16 and 256.
Yeah. So the format it won't work in CPS. So we'd have to talk to AJ to see what he wants to do, if he wants to support the Commander X16. I think it would be beneficial for him to do it, but and what I wanted to do was write something that was cross-platform. You know, I would have talked to him about CPS, but because it's Windows only, I wanted to do something that was cross-platform, and SpriteMate is cross-platform. It's a website, so that's why I'm trying to learn TypeScript as I'm doing this. But yeah, it's getting there. But it does do the overlay. My next target was to do the save, so I could generate some kick assembly files that we could use in our demos, but I ain't got that far yet. Too busy at work. But yeah, so the vision is in Sprite or View or whatever that we can change the dimensions in line. So if you've got 32x32 and you want to change it to a 32x64, then it will change them all, yeah. Or if you want to change it to a 64, I think we can do 8 and 16. Can we do 8 on sprites? Yeah, we can do 8, can't we?
Yep.
Yeah. So it would change the dimensions in line. And same with the colour depth as well, because I've got to figure out how to represent 255 colours on the screen. I mean, he's sort of done it here, I think. Did he do a colour picker? I can't remember.
Probably he's got 16 rows of 16 to display as well. It's a huge palette.
Yeah.
It'll take up most of your screen.
I know. So I don't know.
And the irony is that I very much doubt anyone's going to use 256 colour sprites, because they use so much RAM to store them. You can't have that many.
Yeah. So 16 colours is a good bet, yeah.
It's certainly what I've been looking at, purely from a sprite storage perspective.
Yeah, because
you've got 32 by 32. That's like 32 bytes times 32 per sprite.
Yeah.
Which is 256.
Mm.
Just a quarter of a K per frame of sprite if it's the biggest sprites.
Yeah. Yeah, I suppose, Mikroman. I suppose. But let me get the 16 sprites code. But you've got the ability to change the palette, yeah? Because he put a custom palette already in it. So you have the ability to change the palette. So let's say we want to change that one there and go 00 FF. There you go. It's gone blue, look. It's gone blue. So we can have the ability to change the palette. So as well as
what did you change that to?
What did I change it to?
What value did you set the blue to?
00 B2FF.
Okay.
So if I go, okay, B2 00FF. There you go, it's gone magenta type. But if I click on it, I can draw it on. So if I change it, will it change? That's something I ain't checked. Hang on. 00 B2 apply. Oh, get in there. So as well as exporting the sprite data, I'm going to have to export the palette data as well in the kick assembly. So one thing I need to do is work out how to set the palette, which we touched on in Myriad, and then do an automatic assembly.
Also, the colour palette Little Indian.
Yes.
Which is a real pain. You have to flip your bytes around.
Yeah. But yeah, so I'm getting there. So I've called it Sprite Mate.
Very sexy.
Well, I've called it Sprite Mate X16. What I do need is I need this logo here changing to have X16 on it, so we can change the about box and all that. So I have recognised the fella. I've recognised the fella who originally wrote it. and that's going to be in the about box. So there's going to be his recognition in there. But I want to change the logo. But because I've called it SpriteMate X16, I don't know. I want the X16 logo in there. Yeah, instead of the Spectrum bands. I think they're Spectrum bands. I don't know why he put Spectrum bands in there. But yeah. Anyway, so I am getting on it slowly. But all the other functions work as normal. So if we do flood fill, look, bingo. Got on all the other functionality still works, yeah. If I can find the logo, I'll Photoshop something. All right then, mate. Hang on. Let me tell you what.
It's on the X16 forum or the X16 website, or just Google it. There's images all over the web.
Right. Let me just tell you how big it is.
John's got the source, so he must have the image.
It's an SVG. The image is.
Hello, John here. Thank you for following. Hope you enjoy the stream.
Who's followed? Mooing who? Lima. Welcome in. Yeah, the logo is an SVG, and I haven't got a program to modify SVGs.
Inkscape, John.
Say again.
Inkscape, it's open source.
Inkscape.
Ink, as in pen. Inkscape.
Oh, Inkscape.
Yeah.
Is that Vector?
Ink with a K, John.
Yeah, Inkscape.
Yeah.
Is that a Vector one?
Yeah, it's what I use for doing SVGs.
Oh, okay. Well, I've got the SVG here, so if anybody wants the SVG, yeah, we need a suitable one for here. But what I want to do is I want to acknowledge that the person that originally wrote it had a big influence, and that's why I want the SpriteMate typeface to still be there, but I want it to have the Commander X16 X in there to signify it's a Commander X16 variant. Yeah. So, if you want the SVG, you can grab it from his GitHub, or I can send you the SVG file. Yeah. But I just want to. I want, because he's written most of it. All I'm doing is tinkering, really. And I want it to at least acknowledge that he did most of the work. Yeah. Hey, Statbats, welcome in. I'll have to let me bookmark that Inkscape. There we go. Sorted. So yeah, do you know which font SpriteMate text is in? No, mate, because the text is the SVG, so no idea what font he used. He has, but that's not the font that he's using now. That was a funky font. I mean, to be honest, what does it look like? It's got to be some sort of free font. But yeah, if we can get as close as close to it as possible. I mean, if you load it into Inchcape, ASP, surely it would show.
Yeah, the font's in there, John. I've loaded it into Inkscape, the font's in it.
Is it? Right.
Yeah.
Good. There you go. So, yeah. And so that's as far as I've got. So, the save, I'm going to create a new version of the SpriteMate format, specifically for the X16. I'm going to have to lose the sprite pad stuff because it won't work. I'll definitely try and do the Acme ones as well. Basic, yeah, I mean that's the same. It's just data statements, and then a PNG. Yeah. So yeah, so that's what I want to do next is save. I want to be able to save what I draw in here. So when we do streams and we do graphics, we can save it straight away. Yeah, but it's getting there. I reckon another.
Those graphics streams are amazing. They're just riveting. Last week was just the best stream ever.
Oh dear.
I'm completely sincere. I think.
But yeah, I want to make it a little bit more interesting than. Anyway, anywho. So that's where I am with SpriteMate. So I'm struggling a little bit because I don't know TypeScript, but I am learning.
It's only JavaScript.
Yeah, but it's not quite what I recognise. Yeah, it must be the way he's using TypeScript or something. There's some weird instructions in there. So yeah.
But I need to learn faster because AccuSprite is horrible.
Oh, I know. I know, mate. That's why I want to. That's why I'm doing it. That's why I'm doing it because I played with AccuSprite, and I mean, I don't want to diss the bloke, right? But one thing I've learnt at work is when you're developing something, don't have something else in your mind while you're developing it, because it just doesn't work. And
it's clever. It covers a whole slew of machines and formats, but it's not user-friendly, and it doesn't just getting the sprites out of it in anything apart from its own format is impossible.
Yeah. I looked at the source code, mate, and it is, let's be nice, chaotic. There we go, chaotic. That's a nice word.
So it's like my source code.
Yeah. So, but I took the decision. I didn't want to do just Windows only because we're in an era of more than one platform, and that's why I've not spoken to AJ about if he wants to support X16, because it would be a significant change to the sprite engine. Because I was looking at it, I was thinking, is there any way I could quickly do it to change it? But it would be a significant change to the sprite engine, to the point that if it was me, I'd rewrite it. If it was me, but it's AJ's project. It's AJ's baby. I don't want to step on his toes by forking my own version of CPS. So yeah. I have not seen
Star Wars, mate.
Oh wait, talking about Star Wars.
Yeah.
All right. Should we do some spoilers? They all die.
Business lady dies in real life.
Yeah. Anyway. Spock and Kirk killed Darth. Anyway, so I'm hoping that I'll have this done in the next week or two, hopefully. I mean, bank holiday's coming up, so I'll have 4 days to mess around with it then as well. Hey Rob, welcome, welcome. Anyway, so enough of this. So I can't use that yet. Right, where is it? Have I closed it down? Yes, it is. Right. So this time, what I was thinking was we mess around, and that's something I've forgotten to do. We're going to mess around with sprites. Are the docs in GitHub up to date?
I think
Depends what up to date.
the most up to date. I don't think there's anything better.
Right.
The documentation's properly fallen behind.
Yeah, because I noticed that in the PDF I was looking at, it was wrong.
Yeah, and most of the blogs as well are now next to useless because they're all out of date. Although the sprite pointer date and the sprite format is still the same. That's right, no matter what version you go back to.
Right. Lima says this is as up to date as it can get. So I'm gonna be bookmarking that then.
That's what I've been using as reference for that code I've done, mostly.
Okay. Yeah.
The problem they've got is they've got a lot of brilliant coders and people that really want to get on and do stuff, but they've got nobody that's a proper documentation expert.
Right.
Like they got for the Mega 65. One of the guys was brilliant about documentation and wrote the manuals, all 2,500 pages of them. But there's nobody really that's doing the documentation to that standard, unfortunately.
Yeah.
It's kind of raw data, not documentation as we like it.
Okay. Well, we talked about this before, that the person that was doing the documentation got a bit of a not Michael Knight fetish, didn't he, and lost interest.
Yeah. Well, I don't think he was any good anyway. So
right. So last week we managed to finish, I think. No, we didn't finish it, did we? We got it into a situation where we was happy with it. There we go.
we shipped it.
It was working.
Yeah, we shipped it. Right, let me just make sure it still works. Oh, it might be in high res mode. No, there we go. So we've got Myriad working in standard def character mode, as if it was a VIC-20, yeah? So one of the things we wanted to do was then add the multicolored aspect to it. But to learn how to do the multicolored aspect, it's best to learn it on the sprites and then apply it to the tiles afterwards, because they're basically identically the same system from what I have read. Alright? Now, ROM emulator maintainer here, trying to keep the docs up to date with rechanged. Oh, we've got a documenter in the chat. Nice. Let's make sure we're friends with him. Make sure we're friends with him. Keep him happy, everybody. So yeah, so we've got, so Myriad in its VIC-20 form is working on the Commander X16. It all works, but there is, I don't know if you guys have been playing it, but there's still that wandering glyph every now and then that just zips up the screen in both directions. Every now and then you see this yellow thing going Zff. So I don't know where it is, what's causing it, but we'll find it when we do the multicoloured bit.
Check chat, John, for an updated Sprite Mate logo.
Say again.
check the chat for an updated Sprite Pad logo.
Oh!
Discord.
Ooh. Okay. Hang on, let me get back into Sprite Pad.
Yeah, keep up the good work, mate.
Is that to me or 6502?
No. It's the moving lemur.
Oh yeah. We'll keeping you sweet, mate. Right. So I've downloaded that. We're Sprite, mate. Here we go. Right, let's rename this to .original. Right, let's copy.
Documentation is the worst part of any project,
Oh,
especially one this big.
well, any project, mate. I hate documentation at the best of times, but I have to do it. That is for sure. Right, TypeScript. Where are you? There you are. Command Sprite 16 source image. There we go. Right. So I
Need to duck away for a minute.
Yeah, no worries. Right, let's grab that. Copy that. Paste that into there. Right, so we should have, here we go. Right, so let's rename this to logo menu SVG. There we go. Right, see what that looks like. I mean, don't get me wrong. I was thinking of putting a section, doing a Beep Spriter, changing Beep Spriter to work with X16, but it was. Oh, look at that! Nice. That is nice, isn't it? Nice.
Now you need the 64 with a strike through and an X in place of it on the next line.
Oh, you mean here? Hang on.
That's just text, though, is that?
Yeah, that's text. How about box?
Yeah, but can we strike it out and put an X?
Yeah, hang on. What's strike through and HTML? Hang on. You can tell I use strike through a lot on HTML.
What's HTML?
Oh, it's S and then /S. Right. So S/S X16. There we go.
It's also not Commodore.
Oh yeah. So we could do this.
You could just leave the C and then slash the Commodore out.
Yeah.
And then just put under.
There we go. Right. Has it redone? Is it redone? Looks like it. Right, refresh. There you go. I think leaving the C there doesn't work, mate. I think we need to it don't work. Personal. Let's do that.
No, you're right.
It's minor tweaks, that's all, isn't it?
Yeah. Right. Refresh. Come on.
But leaving it in there struck through sort of pays homage to the
There
fact that it was Commodore.
There you go. That works, doesn't it?
Also, the X16 is meant to be a throwback to Commodore as well, so. Hence the choice of chips and all the other bits and pieces around it.
Yeah. Let's do that. Config version. I need to change the version number as well. It's no longer 1.3, it's 0.1. Right, let that to refresh. There we go. So Sprite about. There we go, that's better. Well, I don't think...
Have you done the documentation for it?
Mate, I'm telling you now.
It needs code reviewing first, mate.
There is documentation, because the guy's done a pretty good job at doing it. But I'll have to tweak it. There we go. So it should say 010. There we go, that's better. Right. Hey, look at that for a logo. Nice. Well done, 6502. I bet he's still gone, hasn't he? Nice. Right, okay. I'll carry on working on that.
Keep up the good work, mate.
Yeah, I'll be there soon, mate. I might host it on the Pi, and then I'll give you the URL so you can try it out. It should work on the Pi.
Just use all your solar power doing that.
I've got 8 Pis running, mate, at the same time, so I'm used to it now. Right. So, back to what we was doing. Talking about. So we've done Myriad, yeah? So to learn the multicoloured part of Myriad, we've got to learn how to do the sprites, because they both share the same encoding system. So let's carry on. So our friend Mr. Saucy did a where is it? Oh, it's not on there anymore. Hang on. More. Hello world. No, that's me messing around with ARM assembly.
Third one down.
That's your engine, mate. That's your engine. I'm on about.
Oh, sorry. Yeah.
I'm on about the one before that. Hang on. I'll open it up from here. 64. No, it's not in the 64. It's this Commander 16. Learning. There we go. So our friend, one Senior Saucy, has created a demo sprite thingy. So here we go. Sprite on integer. So here we go. I'm going to run it. And look, we've got a Space Invader going across the top of the screen. And that's running off the interrupt, isn't it?
It is, yes.
How many did you do?
I think there's 4 sprites with 2 frames each. That's it, I think, on that.
Oh, is that? Oh, that's the UFO, isn't it? And then we go back right.
That's before I worked out how to do multicolour and what have you. And using that awful sprite editor.
Yeah.
My son was built with a 65 CO2 processor.
Right, so did you... Oh, you made an SPR file. Oh, okay. Hex, that'll have to do then. Will I be able to convert that? That's 16 colour encoding, isn't it?
Yeah, 16 colour, 16 by 16, so it's 8 bytes by 16 for each sprite.
Yeah.
The trouble is getting anything out of Acheson in anything other than its own format or raw data is horrible.
Yeah. Yeah. I mean, can you see that hex editor? See if I can boost the sprite on the hex editor. Boost the font on the hex editor. Column width. File size. Okay. Oh. Can't change the font size. Oh well. Hey Docster, welcome.
Can you do Control Plus or Alt Plus on it?
Yeah, yeah. Let's try. Oh, the only problem with that, it makes everything big, doesn't it? Oops.
That's what she said.
Pressed it on the wrong one. I mean, it does do it, but it just. Well, right, okay. I was wondering whether to quickly make a Python script to encode it so we could see it. Well, so anyway, so this is how the sprites are encoded, yeah? So we're talking 16 colours. We're not talking 256 here. Keep that in mind. So each pixel of the sprite is 4 bits in memory. All right. So let me do this. New file. So each pixel of the sprite is 4 bits, 16 colours. So you've got to colours. So you've got to remember, it's like the BBC. Remember the BBC in mode 5 was 16 colours. So for every 1 pixel on that screen, we had to encode 4 bits. And you know the BBC had a weird encoding and stuff like that. Well, it's the same with this, right? So for 1 byte equals, so we're talking like, so that's the first pixel and then the second pixel. So 1 byte is for 2 pixels. Yeah? So you've got to remember that. Got to remember that. So coming back to here, we can see in Saucier's file here that we've got 2 pixels of 0, 2 pixels of 0, 2 of 0, and then 2 of D. Now that is the, and correct me if I'm wrong if I say something wrong, that is the palette color index, not the color itself. It's the index to the palette color.
Correct.
Right. So you could have the Commodore 64 colors in the X16, and white will be 1, you know, black will be 0, and stuff like that. But alternatively, you could have had them the other way around. So 0 wouldn't be black; it would be white. Yeah, it's the index to the color palette location.
I believe colour 0 is always transparent though, John.
Is it?
Correct, yes, always. In every palette, in every line of the palette. So you've got 16 colour palettes. 0 is always transparent in 16 colour mode.
So how do you do black then?
You define colour 1 to be black, and then anything you want to be black, you do in colour 1. And anything you want to be transparent, you do colour 0.
Oh,
It only
right.
changes the background colour to be black because it's transparent onto nothing, so it's black.
Right.
And also, when you set a sprite, you have to tell it which palette you're using. If it's a 16 colour sprite,
That means I need to change that sprite, mate. I've made 0 black.
no, it's always transparent. As Saucy says. The left-hand column of the 256 color palette is always transparent, unless you're in 256 color mode, in which case it's whether you set it to and 0 is black. 0 is transparent.
Right, let me make a note of that because I need to change it. Right. Alright, because I made it in Sprite Made, I made it black, so it's not black. Okay.
John,
Yes.
just drop the text file in Discord chat. That might be more use to you.
Where'd you put it, mate?
Chat in Spyhole chat.
Have you?
Docster, come join us.
Have you? It's not in there, mate. Aha! Now it is.
I've not hit enter. Damn. Stupid thing. That might be easier to work with for explaining.
Right. Let me do this then. Let's grab that. Have I got one already open? Too many windows open. Too many windows open. Right, let's put that in there. Aha!
That easier.
Yeah.
Could probably be better if it were broken into 4 bytes at a time, because then it'd look even nicer. But
Yeah, because this is effectively 2 rows, isn't it? 1, 2, oh, 2 and a bit on the sprite.
I don't know, it's just what hex edits spat out is the hex format.
Yeah, 2, 4, 6, 8, 10, 12, 14,
It's 3
16. So it's there, isn't it? That's one line. You said it was 16 by 16?
Yeah, 4 bytes is 16 pixels, because each byte is 2 pixels.
Yeah, 1, 2, 3, 4, 5, 6, 7, 8. 2, 4, 6, 8, 10, 12, 14, 16. But that's 8 bytes, not 4.
Sorry, yeah, 8 bytes is 60. Yeah, that's right. 8 bytes is. Ooh.
You're
Yeah.
getting me confused.
I know. I got confused myself when I was trying to do maths to work out where the bloody hell they were in Vera space. When I've got a mixture of 16 by 16 and 32 by 32, it gets horrible.
Oh, right, okay, so I'm not going to do it all. I'm just going to do a couple of rows. There we go. So there's three rows of sources sprite of the first sprite, which was the alien with the legs. So you can see he's using 13, D's 13, yeah. Palette index 13 to show what the colour is. So we could, if we wanted to, we could change that sprite into a different index, and we could make the top line have a different. In fact, let's do that. Let's do that. Oh no, I want it in hex editor, just to show that we are talking on the same. So if we do that one, so that's 1, 2, 3, 4, 5th line down. So if we make that right, so we've just changed those to CC. So if we run it now, the first sprite should have a line going through it. There we go. Can you see it?
On every other frame, yeah.
On every other frame, yeah. So you've got to remember, for every 1 byte, that's 2 pixels. So for a 16 pixel sprite, that equals 8 bytes. 32 pixel equals 16 bytes. That's for one row, remember? And 64 is the max, isn't it? So 64 is 32 bytes per line. Per line. So, with that knowledge in our hands, we should be able to take sources sprites here that we've got, because we'll use them, and we're going to try and put a sprite on the screen. We're not going to use his little program, but we may nick some stuff off it to figure out what we need to set up. Yeah. Right. So I think I'm still one too big. There we go. That's better, is it?
What she said.
The problem with this, it doesn't show you what the zoom level is.
That's too small. I can't read it.
You can't read it?
No, seriously.
Oh, put your glasses on.
I've got an 85-inch TV and my glasses on. And I still can't read it.
And you sat 4 inches in front of it.
Pretty much, yes.
Right, hang on. I need to find out what the zoom level is. What's the zoom level?
That's perfect.
The leftmost pixel of each byte representation is always made from the high bits. Yes. Yes. So pixel 1, pixel 2. Yeah. Right. I was getting distracted. Appearance. Zoom. Oh, there's no zoom level. Come on.
What a shit editor.
Here we go. Reset zoom. Oh, we was right anyway. Right. So, what do we need to set up to get the sprites working? So, where's the Vera? What do we need to set up to get the sprites working? So I assume we've got an address to put in somewhere.
You need to put the sprite data in Vera memory. You need to set up a pointer to that Vera memory in the 8 bytes of sprite information. You need to enable sprites somewhere in 9F range. And yeah.
Okay.
Start off with the 9F page. There's an enable sprite somewhere and one at low parts. Near
Yeah,
top.
it's just a byte.
Okay.
There. 2C.
2C.
I think it was 2C. Keep going
Oh,
down.
29.
No.
29.
No, 2C. No, 29, you're right.
29.
You scored it too fast.
Yeah. So we need to enable. So we need to set that
No.
bit on, yeah?
Correct.
Right. Okay. Let's get back to here. So we're creating. Okay. Copy. Paste. Right. So this is effectively. Oh, where did that paste to? Where? Oh, it's there. Oh, stupid machine. Right, so this is basically... Oh, shut up. Right, So this is effectively episode 5 of learning X16, if you ignore the myriads. Right. So we'll back up the Vera like we've got there. We'll get rid of all that. Get rid of all that. Get rid of all that. Right. Right then. So, have we got that in the Vera constants? That's the voices. Voices.
The ones in your head.
Yeah. That's you guys at the moment.
Spooky shit.
Right, so it's that one there, yeah? Right then. So, LDA, that, and it with yeah, that blanks it out.
Just over it. There's no need, just over it.
Yeah, I know, but we need to
because all the hand does is unset it. So you might as well just over it to set it, because you're going to force set it.
John,
yeah.
to remind you of oh, you've got an off as well. Okay.
John, this is global. This is global sprites. Because you also have to enable individual sprites.
Right. But we'd want to be able to turn them all off and turn them all on, yeah?
Yeah, but what I'm saying to you is put the word global in there.
Oh.
Yes, yeah. But individually you can enable and disable them anyway.
Yeah.
Okay.
Don't confuse him mooing. I did that last week or week before.
3, 4, 1, 2, 3, 4. Right. So, and it to make sure it's off. To make sure it's on.
John, you can use TSB and TRB, don't forget.
Yeah, but you can only use them on 0 page locations.
Yeah.
Oh no, it's branch and jump you can only use on. Can you use TSB on any address?
Oh, I can't remember now. I don't have my laptop on me.
Hang on. Hang on.
I'll be back in a second.
We'll find it. We'll find it.
No, I believe him. I know it was the branch test. Branch on bit test you can only use on 0 page, which is a bit of a pain in the neck.
TSB. Right. But why okay, why would we use TSB? Because
you want to test a bit. I don't know why you'd use it just here, because it seems a bit pointless, but
yeah, that's why I was asking, why would we use TSB? Because we're not testing the bit, we're trying to clear it and set it, yeah? We're not saying, is it on or off, yeah?
To be honest, I'd just order it with on and have it done with. But
yeah. I'm just, you know me. Oh, look at all this chatter. What's going on? Lima, there is a command. If you want to get my attention, just type in that.
Oi, John, pay attention
don't
to
teach him
chat.
That. he's gone writing up and I haven't seen it all, and we're all talking about TSB and TSR. Yeah. So yeah. So that's test. Is there a set then? Set bit.
It's test and set. There's TSB, test and set, and TRB, which is test and... Is it TRB or T... Yeah, TRB is test and reset.
Oh, hang on. So TSB is right. So that sets the bit.
Yeah.
Okay. All right. Let's. So TSB.
TSB followed by the number.
Is it followed by the number and then the memory address, or is it the memory address followed by the number?
Yeah, good question.
Oh, I wish this site had given me the answer.
You have to, that was the problem with it. You have to load the accumulator anyway, so you might as well just or it and save it.
Yeah.
Because you can load the accumulator with it, do the test and set bit, then write it back. But it's the same number of instructions.
Yeah.
It's boring.
Yeah. Okay.
But it's very handy if you want to check a particular bit.
Yes. Yeah. Which we do quite a lot, if you remember. Hang on. He's saying we misunderstand. The test part of TSB is for setting the 0 flag. Right, okay. But TSB...
You load A with your enable flag and then test and set bit against 0 DC. And it'll set that bit and return whether it used to be 0 or can't remember.
Right, so, but TSB is usually used for the pattern LDA or store. TRB is usually for AND. So we don't need to load the accumulator to use TSB then?
Yes, you do.
So it's LDA, TSB, STA?
No, load LDA with the mask, your global sprite enable on, and then TSB, the address.
Oh, I get you now. Oh, I get you. All right, hang on. So, I need to understand this. Right, so we're saying if we do this, that, and then do TSB, the address, does that store it? That will store it back into that memory location.
With that bits, whichever bits are high.
It acts direct on the memory location, not the accumulator. So it applies the math to the memory, not to A.
Right, but we have to load A with the bit we want to set, yeah?
Or bits.
Yeah.
Multiple, if you
bits.
Or bits.
Yeah. And then it's what you would have ordered on, but then it applies directly to the memory address.
Right, okay. Right, I've put that in. Because, we're trying to make use of the new CPU things.
We're learning.
Yeah. So that's then turned on the fact that we can use sprites, yeah?
Yes.
Right. So then we need to do a copy, don't we?
John, you also need to set where the sprites are going to go, so they can go below screen 0, between the two planes.
That's part of the 8 bytes of the sprite data. There's a load of bits to set up in there.
Is it? I thought there was a global for it.
No, it's individual per sprite.
Okay, fine.
It caught me out. Why are my sprites not visible? Why can't I see them?
Right. All right then. So we're gonna nick your Space Invader sprite. So let's let's stick that in here. So star equals, where are we going to put this? Just fair. So bin, no, coders. Yeah, that's the one. There we go. That's it. So sprites. Right. Oh, I need to do that, don't I? So we've got a copy function. So we need to figure out where we're going to put them in memory.
The default is 130000, but I think I stuck them at 0 to start with because it doesn't matter. You're not using screen 0 anyway.
That's exactly what I was going to say.
It's easiest to put them at 0 because it makes the calculations easier. When you start adding 130000 to everything and then shifting 5 bits to the right, it's a nightmare. Sorry, we distracted you, John.
No, I was just trying to think, because if we have a character set as well, because in Myriad we put the character set at 0, didn't we?
Did we?
Yeah. So where do you say the default is?
13000, but that's only suggested.
That's only.
You can put them wherever you want.
Yeah.
On 32 byte, is it 32 byte boundaries?
Well, it'll be like the C64, won't it?
No. Yeah. It's on a 5-bit boundary, basically.
Well, it'd be like the C64, won't it? That they were on 64-bit boundaries, weren't they?
Yeah.
So we need to do a copy now. When did I do a copy? No, I didn't do one there, did I?
If you've got my version of the macros, there's a copy RAM to Vera.
Copy data to Vera, yeah?
Yeah, in my version of macros.
Yeah, I put them in there. So sprite data. So
The first parameter is in normal RAM. The second parameter is in Vera RAM.
right, okay, that's that. Oops. Oi, just give me what I asked for. So VRAM including the 1, yeah?
Yeah.
So, oh, you've got the end. Hang on.
Or just a length.
Right, so that should then copy that data into Vera.
Just an aside, but I really like Shallan's method where you just put underscore sprite data at the end to top and tail it. Just semantics, but it always looks elegant.
Hang on, say that again, mate.
So instead of using sprite data end,
Yeah?
yeah, Simon always put underscore sprite data to designate that it's the end of the sprite data. So your label's matched up, but there's an underscore at the end one.
Oh, you mean like that?
I don't know, I've got 3-second lag.
Yeah. I've done that in the past, but
Yeah.
when you do sprite, it looks a bit messy.
It's personal preference, mate. I don't care either way. You just
Yeah, no,
I would like to.
If you start doing maths around it, you can end up with minus underscore, and it looks confusing. But no, that's fine.
Yeah, good point. Good point. Either way, I was just
Yeah, no, it's fine.
passing the time.
Yep, I get what Moon's saying as well, but since in general we're talking about writing games, so we're never going to be going back to the mouse as such.
Yeah, that's a lot of people pointed that out because Sprite Zero is the default mouse, but we're never going to have a mouse in this game. So,
Oh, is where sprites is. Oh, right. So one sprite is dedicated to the mouse if you use the mouse. Right.
no, but the default sprite for the mouse is Sprite Zero.
Oh, right. Okay. Well,
But you have to turn the mouse on. If you're not using it, it doesn't matter. But
yeah.
there's a few people who said best practice avoid using Sprite Zero. This is just ticking about, so it's not massively important. But
All right.
And if you're in a game environment where you're not going to come out without rebooting the whole machine anyway, it makes no difference.
yeah.
No, it's fine, Maureen. You keep feeding us information because we don't know everything, or we can't find it all.
No. Yeah. We're all here to learn.
Hopefully, someone's writing all this down.
Well, luckily I download the video, so.
I mean, there's plenty enough sprites, so avoiding Sprite Zero isn't a big issue, really, is it?
No. So we've put the sprites in the memory, so I presume we've got to set the memory address, the base memory address of the sprites, yeah?
Yes, and that is at 1FCOO is where you set all the sprite attributes up.
1FCOO. Oh, right, okay. So it's in Vera memory, not in.
Yes.
Oh, hang on.
Yeah, all the pointers are in Vera RAM. Yeah.
In blocks of 8.
Yeah, hang on. 1FCOO, right. So 8 bytes. So where's these 8 bytes then?
It's further down, just past the palette.
Oh, right. I didn't go far enough. Ah, right. So
And you have to set up basically all those 8 bytes for each sprite.
So the address is from bit 5 to bit 16. So, hang on. So if we're using 1, 3, 1, 2, 3, like that. So how many bits in the high one?
You have to shift it right 5 bits to get rid of the bottom.
Yeah. So we've got to shift it right 5 bits, but the 6, so 8 and 13, 14, 15, 16 and 4. So the top 4 bits, right, hang on, top 4 bits is just 1, and then we want that bit minus that 5 at the end, yeah, to go into the 0.
Now, do a shift on it and you'll see what it becomes done if you do a bit shift right 5.
It's not working.
You can do it in assembler though. Just do.
Yeah, but to visualise it, no, down a bit, the right shift thing.
Yeah.
Otherwise,
Hey Gary, welcome in, mate.
Help,
Welcome.
Gary. Help, cold hands.
Right. 1, 2, 3, 4, 5. Why is that not bit shifting?
5.
Oh, have I got to put 5 in it? Blah. Hang on. 1, 3, 1, 2, 3, 5. Right. Because
Right. That is, the first 4 bits are address 16 to 13, and the bottom byte is the address 0 part of it.
So, okay, so I'm trying to understand.
Yeah, just getting your head around it.
Yeah, so in the 64, right, we set the base memory address by setting the CIA chip for the banks, yeah? And then we had a pointer between 0 and 255 which pointed to the 64-bit chunks, yeah? So with the X16, we're not doing that now. We're actually saying this sprite, whatever number it is, sprite 0, sprite 1, is actually this memory location.
Yes.
It starts at this memory location. Yes.
So each sprite has to have its own memory location specified.
Correct.
Okay, that's what I'm trying to get my head around, yeah? Because we're no longer doing sprite pointers. We're actually saying, oi, you, sprite 0, is there. Oi, you, sprite 1, is over there. So then
you can change that address and it'll point to a that's the pointer to an image in Vera memory.
Yes.
So this is sprite 0, and those 2 addresses point to where the graphical image data is in Vera memory.
Yeah.
If you change that address, you'll have a different image associated with the same sprite.
But you can set all the sprites to point to the same image, and they'll be identical.
Yeah, same thing. Oh, it's just pointing to a picture in memory, basically. But you've ditched the bottom 5 bits of the address.
So, just trying
so you can only step up in 30, well, 1, 4, 8, 16, 32 bytes at a time, yeah.
So, just trying to drop it down to the guys that are not as advanced as us.
We're not advanced, I'm still learning.
That effectively the memory address is equivalent to the C64 pointer.
Yes.
In simple terms, yeah.
And that's what I'm trying to get. In simple terms, that memory address is the equivalent to the C64 pointer for the sprite. In simple terms.
It's exactly the same, because that pointer in C64 has got the bottom 5 bits set to 0, hasn't it?
Yeah.
So it's the same thing. Because it's 64-byte sprite, the bottom 64-byte bits are always is always 0. That's 64 bits, but
yeah,
the 5 bits that make 64.
So in terms of
it gets a bit more complicated when you've got different size sprites, because that can only reference to a 32-byte address space. But if your sprites are 16 by 16, that's wherever it is, however many bytes. It's more than 32. An 8 by 8 is 32 bytes and everything bigger, so you need to jump up in bigger jumps.
Yeah. So there is a minimum. So, I mean, 8x8 for a 16-bit, 16-color sprite would be 4 bytes, 64 bytes.
That's why it's 64 bytes. The smallest sprite you can have is 64 bytes, which is an 8x8 16-color.
32 bytes.
No, I was just about to say it's 32 bytes, but that still works in the address, because bit 5.
Yeah.
So basically, in the address space, if you wanted to reference an 8x8 sprite in the address space, you just add in 1 to the address.
To move to the next one, yeah.
To move to the next one, right? So this is what I've got to try and get over to the guys that are watching, because, you know, they are probably not understanding what we're trying to say. Yeah.
Draw it out.
draw it out. So.
No, it's complicated to get your head around if you're new to it. And like Marine says, there can be 8 by 8, 8 by 16, 16 by 8, 16 by 16. and then working out how many bytes that is, and then converting it down to getting rid of the bottom 5 bits.
Yeah.
Yeah.
So, what we're saying is the address. So for the address for the sprites, pointer, we'll do that. Pointer address for the address bytes has 2 components. Has 2 components. I'm trying to make this as. So we have the low address portion and the high address portion. So the low address portion only addresses bits 5 through to 12. Only addresses bits 13 to 16. Right, so put it in simple terms. 8 by 8 sprites, oops, are 32 bytes each. (16 color mode). Right, so let's just multiply this up. Oh, John, come on, wake up. Right, so 16 by 16 will be 32 bytes.
128 bytes.
What, for the 16 by 16?
Yeah, it's 4 8x8s. If you think of it as 4 8x8s in a box,
Yeah.
it's 4 32s.
What am I doing? 8 sprites are 32. What did I do? Why did I put that?
Right.
Hang on. Why did I put
8 by 8 sprites are 32 bytes each in 16 colour mode. That's right.
Yeah, why have I got that 8 in there?
Right,
That's what
yeah.
that was confusing me. Hang on, let's get rid of that. 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 Right, so 32, so that would be 128. And then 128 times by 4 is 512.
Yep.
And then that would be 2048.
64 by 64 are huge.
Yeah, 2048.
And if you do that in 256 colour mode, it's 4K for one sprite.
Yeah. All right.
You soon run out of memory.
We'll put them in as well. So let's do the 256. 256. 256. So 256 is 1 bit per byte. So that would be
64.
it is 64, isn't it?
Yeah, everything doubles.
Everything doubles.
Vera's got 128k SP.
Right.
You start shoving 4K sprites in there, you don't get very far.
And 128k includes screen RAM as well, which is
you've got
just
screen,
4k.
Colour and all the other stuff that's preset.
Well, 16k, isn't it, per screen?
Right. So now you've got to think about these two portions, yeah? So if we start at 13000, for example, yeah, in Vera memory, right? So you're going to work out the addresses part. So let's put that down here. So if we start in Vera memory, so that means the address equals, right, 1 3 1 2, no, that's 3. In fact, that's not right. I was right to start with. Right, so that would be the address, yeah? That would be the address of the very first sprite, sprite 0. But remember, the low address is bit 5 to bit 7, yeah? So that would then convert, so after shifting 5 bits would equal, right, so where's my calculator? I've got it here, haven't I? There, that's it. So 1, there we go. So that would then convert to that. So once so this is your high portion, which is the 4 bits that needs to go in there, and then you've got your low portion, which is this bit here, which is the 8 bits that need to go in there. But if you want to if you have, let's say you load 10 sprites, yeah, then you're not going to be adding 32 bytes to this, because you would be adding 32 bytes to this address, but you don't need to, yeah, because if we convert this into binary, so let's do that. That is 1 2 3 4 1. That's 5 bits there, yeah? So let's do the next one. So that would be that. And that would be that.
You need an extra 0 on that, John.
Do I? What, the 128? Oh, yeah.
On all of them.
Well, hang on. 1 2 4 8 6. Oh, yeah.
If you throw away the bottom 5 bits, so the first bit that matters must be something that changes.
Yeah. Them two are the same. That's not right. Oh, yeah. I miscounted. Alright, but so that's what those intervals are like for the address with its full address. But when you're talking the address pointer, which is different, you're talking which would end up being like this, that. So all you have to do is when you're loading up the sprites, for an 8x8, you're only adding 1 to that address portion. For a 16x16, you're adding 2. For a 32x32, you're adding 4. And a 64x64, you're adding 8. I think.
No, I think that's wrong, John.
Why?
I'm sure you had 4 for the 1 to 8.
Oh, hang on.
So you might have. I ain't
Yeah,
counted all your
no.
zeros,
I'm a 0 out, aren't I? Because it's 2048, not 1024.
Yeah, but I know when I'm counting up for 16 by 16 sprites, I had 4.
You had 4?
Yeah, because it's 4 8 by 8s.
1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6.
That should be 7 zeros.
Yes. Because it's 16's missing, isn't it? So 1, 4. So that's 2. That should be 4. Because it's 2, 5, 6, 5, 1, 2. So it's steps of 2, isn't it? 1. So 2, 4. So this should be 6.
1, 4, 16, and 64.
Yeah. So 1, 2, 3, 4, 5, 6.
You base out in 2 zeros every time.
128. 1, 2, 3, 4, 5, 6, 7. That's right. 1, 2, 3, 4, 5, 6, 7. 128, 2, 5. That's 1 too many zeros.
Just mouse over the 1 to 8, doesn't it show you?
No.
The 512 should be 8 zeros, shouldn't it?
That's what I was. 1, 2, 3, 4, 5, 6, 7, 8. Yes, that's right. So that would convert to 4.
And then it's 2 more zeros for the next one.
Yeah. Hang on. Missing
But if
zero
you forget
there.
binary, it just goes 1, 4,
1,
16, 64.
Yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh. Hang on.
It should be 10 zeros because 2 to the it's 2 to the 11, which is 2048. So it's 1 and 10 zeros, and then that equals 1 and 6 zeros.
Yeah.
The only complicated thing is doing it in binary. The binary doesn't matter.
Right. Hang on. I've just. So it's that. This 2, 5. Right. So 512 is that. 1, 2, 3, 4, 5, 6, 7. Oh, that's not enough. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. That should be right. Hang on.
No, you need another 0 on 1 to 8.
Yeah.
But your answers after the equals are right.
Yeah, which is confusing me. 7, 8. And 32 is definitely that. 1, 2, 4, 8, 16, 32. Right.
I know this doesn't sound like me, but this bit's way easier in decimal.
Yeah.
I take back everything I've said in the last 20 years.
That's right now, though, isn't it?
It is right, but it's more confusing.
7.
Because basically you're adding
I think you've got
32.
too many on the last one now.
Hang on, I'm just double checking. That's not right. That one's not right.
You've got 1 too many on that one now.
Yeah, 1 too many. Right. Okay. So For an 8x8 sprite, you add 1 to the address pointer. For 16x16, you add 8. 32x32, you add 16. Yeah, 16. And a 2048, that's 128. No, that's 64. So you add 64. Ugh. I'm not working that one out. Sod that.
Nobody in their right mind is using 256 colour sprites for anything other than demos.
Yeah.
It's that you don't have the space to store them.
Anyway, so what I was trying to get to was you don't have to do your bit shifting if you work in these values. Yeah? Because you don't have to work out the full address and then bit shift over to say, right, that's what I need to store. You just, for 8x8s, just add 1. That's what I was trying to get across. Don't have to work out the full address and then bit shift it over to get your low and high portion.
No, once you've got your base, you can just add.
Yeah. Right. Okay. Oh, that was way longer than I anticipated. So we've loaded the data into Vera, so we need to now set Vera's data, not the F registers, but the Vera data. Do we have that in as a constant? The sprite, where the sprite data is.
I did, but
Oh, it's there. Look, yeah. Sprite. What's that? Sprite. Oh, sprite reg base. Okay. Sprite reg base. So we've got that. So I'm just wondering if we need to do something like this where we've got the offsets. You know, where we have the offsets.
I thought about doing that, but they're not actually named, so you can make them up. I think that's what I did.
They're not named. Okay.
No, they're just references 0 to 7.
Okay.
So I did call them things like address low, address high,
Yeah.
and things.
Right. So.
Just make it up as you go along.
Right. Right. So, what's mode? Oh, that's the
4 bits
4
or 8
bit,
bits.
4-bit and 8-bit. Yeah.
Ignore it, leave it 0.
So I'm going to call it sprite address high offset, and then we'll have another one where it says sprite mode offset. Right. I presume X and Y is the position, yeah?
Yeah, that's in the similar way, but it's like bottom half and then 2 extra bits.
Yeah. So sprite position X low. Sprite.
The X and Y are also signed.
I was just going to say, as a tip, and hopefully people can understand this when I say it, there's only 2 bits in the high part that are actually used, so it's signed, so it's basically plus and minus from the edge of the screen. But the other 6 bits don't care. So unless they change something in Vera, I treated that as an 8-bit number for maths purposes and let it become negative. So -1 is all F's, etc. as a 16-bit number.
That's what I did too.
That way you're not trying to mask off the bottom 2 bits, then work out whether it's negative or not. And no.
Yeah, that's exactly what I did, mate.
So 2 bits are negative,
No, it's a.
or
it's
it's
a
the
nine-
9th bit is
Sorry, a
negative.
10-bit number. Yeah,
Yeah.
but if bit 9 is a 1, then it's to the left of the screen. If all the bits are 1, it's 1 pixel to the left of the screen.
Yeah.
So it's like 2's complement.
Okay.
So, yeah, if bit 9 is a 1 and all the rest is 0, it's all the way over to the 256 pixels off to the left of the screen where you can't see it.
Alright, so we got the collision mask offset. Sprite dimensions offset.
Bytes 6 and 7 you tend to set and forget unless you want to flip your sprite or something.
Yeah, and then palette offset, sprite palette.
And I'll leave you to read up all about collisions and then work out how you're going to use it because it's horrible.
Right, so we've got the address offset, mode offset is the same number. Then we've got X low, XI, Y low, Y high. I've done collision mask offset because that's the biggest thing, but it's got Z depth.
Z depth is more important than mask because mask you'll not use. And palette is 7 as well.
Yeah. And flip, I don't think we need to know where they are, but we can use the Z depth offset or the thingy to do that. Right, so dot const sprite register length equals 8. So that's every 8 bytes is the next one, yeah? Yeah.
Yes.
Right. So, sprite mode 16 color equals 0. Two, 5, 6. That's 80. Oh, I see what you mean by Z depth.
That determines whether you can see it or not.
Yeah.
Because against a standard text screen you cannot see it unless you bring it right to the front.
Yeah. So disabled is 0. Oh, forgot some carriage returns in there. Right, so disabled between before layer 0. So before layer 0 is 1, which is actually 1, 2, 4. Z depth layer 0 layer 1 is 8. after layer 1 is 16. Don't need that. For instance, if you want to know where on sprite it overlaps. All right then, Gary. Oh, you got to catch him out.
He's on about the cut. Right, Gary. The collision mask is a whole thing in itself.
Yeah.
Let me just check that. The Z depth thing is 1, 0, 1, 2 or 3, John.
Not
It's
one,
basically 2 bits. Yeah. It's 0 disabled, 1 behind, 2 is in between, and 3 is in front.
Yeah, but in terms of the byte values, it's 4, 8, 16, yeah?
Hold on. 4, 8,
No,
12.
12.
12. I didn't realise you were doing it by byte, yeah.
Yeah, C's right. 4, 8, 12. Right. Yeah, I'm trying to do it by the bytes so we can just store in ANDs, yeah? So, right, height and width. So, sprite height and width 8 pixels equals 0. So 16. So it's the last 4 bytes. Oh, hang on. Oh, hang on. I've got this wrong.
It's 2 bits per.
Yeah.
And they're independent.
They're independent, yeah. So 8, 16, 32, 64.
sorry, mate. I'm going to have to do one. I've got a really early meeting tomorrow morning.
Yeah, that's not a problem, mate. Thanks for joining.
Catch you on Wednesday. Always a pleasure.
All right, see you later.
Later, guys.
Night, Andy.
We're not going to get anything up on the screen today, are we? Right.
Yeah, it doesn't. Basically, you just write 8 bytes into there, and your sprite will pop up on screen once you've got the numbers worked out.
Right. So the width is bits 5 and 6. So 0, 1. One is 1. No, wrong side. 1.
No, you're right. If you're doing it to the mass, that's right. 1, 0.
No, it's 1, 2, it's 0, 1, 2, 3. So 0, 1 is bit 5. No, bit 4. That's right. 2 is that, and then 3 is that. No, it's not. Oh, come on, John, get a grip. Oh, I need to do it in binary. 1, 2, 3.
1, 0, 2, 0, and 3, 0.
Yeah, I got there in the end. So this is going to be 0, 8, 9, A.
No. What Moon says.
No.
48 is
40, it's 4, 5 and 6, isn't it? 4, 5 and 6. No. No. Oh.
Keep going, John. Go on.
Sod this. Sod this for a game of soldiers. 1, 2, 3, 4, 5, 6, 7, 8. 0, 1, 1, 2, 3, 4, 5, 6. 1 0 1 2 3 4 5 6 1 1 1 2 3 4 5 6. There you go.
Now you can mouse over them and see what they are in real numbers.
I was right first. Well, maybe not.
Those are right.
Yeah. 40, 80, C0. Okay. Oh dear. It's too late in the day for this. Right, what else we got to do? Done them. That's it.
That's it. All the other stuff can stay at 0 for now.
Yeah. So the only other thing I want to put in here is this. So sprite 16 color 8 by 8 increment equals 01. Yeah. Because we ought to put this. We ought to put them in just to help out, don't we? Right. So 1. That's 4.
You're gonna have to add more later when you do 16 by 8s and 8 by 16s and whatever.
Yeah, we're dealing with squares at the moment. I'm not going to.
Yeah.
I'm not going to. Right, 1, 2, 3, 4, 5. That's 6. So that's 32. 32. Oh, John, 20. 1, 2, 3, 4, 5, 6. Yeah.
Right, Rob.
Oh, see you later, Rob. Take care.
Not 60. 4, 4, 16, not 32. No, your first one's right. 1, 4, 16, 64.
Yeah, 1, 4.
Why don't you put me decimal? Can you say it'd be easier?
1, I was 4, 16. One, 2, 4, 8, 16, 32, 64. Oh dear.
No, hold on.
That's it. Yeah, even Lima's agreeing with me. Lima's agreeing with me.
Yeah, yes, now you got it right. See, he knows what he's on about.
Yeah. Right. I don't want to put the other connotations in there because we're still just dealing with squares, but we can add to the constants file later.
Yeah.
Right. So, how does the sprite know when to turn on then?
Layer.
Oh, layer. Right. Okay.
Well, Z depth, should I say.
So that defines whether it's on or off, yeah?
Yeah. Basically, if it's 0, it's off, and then you can have it at the back, in between the two layers, or in front.
Right.
So you've got a global switch that enables sprites, presumably internally on Vera, that turns the sprite engine on and off. So saving stuff.
All right then.
That's the other option. Just stick them over on the left-hand side out of the way.
Yeah. Which we sometimes do in the 64 anyway, don't we? Don't bother turning them off or on, just put them at 0. Then right, that should be it then. Yeah.
Yep.
So, gotta. Come on, John, get your brain in gear. So we've copied them across. Now we need to set up. So if we want to turn on sprite 0, right? How are we going to do that?
You need to load 8 bytes of data into
Vera.
the sprite 0 location, or whichever sprite you want it to be.
Yeah. Okay. Right. So, address.
You've got a macro to select address already.
That's that one, yeah?
Yep.
Right. So, set up. So, Vera. Oh no. Sprite address. Node. Xpos. YPOS. Right. Okay. Yeah, right. Oh. So he times it by 8. 2, 4, 8. That will give us our offset. Hey, night, Fairlane.
Right, mate.
So that will give us our offset to work with. So, oh, how are we going to do that for macro? Oh, that's annoying.
I told you sprites were fun, didn't I?
Yeah.
That's why the second program I did, the one that's got multiple sprites on the screen using my full engine, it cycles through all 128 or however many you tell it you're using. So I can just start at the beginning and step through 8 at a time, but calculating where in various space you need to write to, you've got to do a lot of, because it's basically, I mean, you can treat it as 16-bit, John, because you can forget the 1 in front, because that's always there.
Yeah. But the problem is, on a macro, it's a hard-coded number. You can't use anything
I
that
know,
works out.
that's what I mean. So you've got to multiply that by 8 and then add it to F300.
Yeah. Yeah. But then we've got to determine whether we're going to use byte 0 or byte 1.
Doesn't really matter.
No, it don't, because once we've finished with it, we don't care. Right, okay. So, add sprite.
You can use any 650 assembler called ends, but ideally you want one that supports 65CO2 if you want to do it in full.
Which is that, but minus that. That, oh, we're in macros, aren't we? Yeah, so it's always going to be erroring. Right, so we add that. That gives us our $128 times 8.
2K.
Oh, that's scuppered, that, isn't it? All right.
You've got to work in 16-bit.
Yeah. Right. So we don't need to worry about the low bit. It's just that bit. Okay. Don't need to worry about the low bit. So we will do, give me the higher bit of that. What do you mean syntax error? Oh, you're joking me, yeah? Oh, I'm going to say a high byte of that. So that should be FC. So we do the sprite number, carry up be set. Oh, will it? Oh, hang on. So we have 128 sprites, yeah? Rats.
Yep. You shift that left 3 times, you've lost a couple of bits.
Lost a couple of bits, yeah. Okay. I'm not too sure that's going to work, but we'll see. No, it won't, because it's inside the macro. Okay, I got to rethink this. Yeah, but the problem is with 128, if you shift it 3, it'll be 0. Because 128, shift it once, will go straight into the carry. Oh, I see what you mean. I see what you mean.
Hello, John here.
Okay.
Thank you for following. Hope you enjoy the stream.
Say hello, who's followed? We don't bite. Say hi. Right, okay, so I see what you mean. Right, okay, let's see. Right, you're saying that you should be able to do this. Right.
Yep, that gets you the low byte of the Vera address, yeah.
So we want the low byte and then the high byte there, yeah? So this is this is the low byte, yeah? This is the low byte.
Multiplied by 8, yeah.
Yeah. And the low byte, we don't need to add anything to it, yeah? Because we've already said it's 0 to whatever. We don't need, so we just need to store that straight into the registry, don't we?
Yep.
The Vera address here. So let me just put that there. So we don't need that. So we do that. So we put that away. Then we LDA.
Yeah. You don't need the add.
Yeah. So we do.
But you do need to add FC to that.
Yeah. But then we can clear the carry because we know we're definitely not going to have a carry clash. Add that and then store that in medium. No, it's high, isn't it? Store that in high. And then 1 goes in that other one, doesn't it? Does 1 go in that other one?
I can't remember how it worked.
VRAM address 16, bit 0. So that's got to be a 1. That's always got to be a 1, hasn't it?
Yes.
So we load 1, or it with that, and then store it.
I can't remember.
No, yeah, because the auto increment, because we haven't set the auto increment, have we? So we need to set the auto increment as well, don't we? So
yes.
So
and that's right.
Yeah, so 0 for that. So it's 4-bit. So we're going to go in ones. 1, 2, 3, 1. Yeah. So yeah, that's it. Yeah.
You just do that. You don't need to do any magic because it's always going to be there for sprites.
Yeah, yeah. So we've worked out where the address of the sprite is, and we've set the Vera bank. Right, so we can get rid of that.
You don't need to worry, just store it. And you don't need line... What's line 150 and 151 doing?
Well, the hang on. No, that's just left over. No, but the reason why
I was confused for a minute.
yeah, the reason why I'm more in it is because there's a nibble increment and a nibble address, and that DECR.
I've got no idea what they do unless Mooing can tell us, because there's note in the documentation that I've seen.
Well, that. Don't worry about. Okay. All right then. Don't. He says don't worry about it, so I'm not going to.
Do they actually do anything, or is it? Ah, right. Yes. That's probably why, because I've not looked at that at all yet.
Oh, the FX. Is that the sound effects or?
No, it can assist with vectored line drawing from what I've read or something like that.
Yeah, I was reading about that. I thought that was very clever, not having to work out where to point your pixels. Getting all steamed up, all this brain power. Getting all steamed up. Right, so that's set the address. So now we're using, do we need to make sure we set it to 0? That's deselect. Is it deselect?
Yeah, a DC select is, do we need that for this? No, because you're not writing to anything DC select relevant.
So all we need to do is don't need to worry about that for setting addresses. Yeah, but if we're talking to Vera data 0, don't we have to tell it that we want to use Vera data 0?
You've already done that.
Have I?
Or have you?
No, I haven't. I haven't touched the control. So we need to do this if we want to use data 0, yeah?
Yeah, you need to...
There. Yeah, and... Whoa. So we just and it to blank out the last bit.
Yeah. Again, now you just got to write 8 bytes of data to...
Yeah, so that's it. We've just got to write the 8 bytes of data. So, sprite address. That's all right. So, LDA, now I know how to do it. LDA hash the lower part of sprite address that 5. No. That way 5. So that is that, and then we store that in Vera data 0. Then this is the high part of that. Something, my voice in the back of my head shouting at me. Oh yeah.
Well, it's
Oh.
data 0 wrong.
No, it's on about mode. So you need to OR that with the mode.
Correct.
And then store it in. Oh, I'll do that. Okay. Then
You're using the mode from your constants that's already bit shifted, yeah?
yeah.
Okay.
It makes it easier than having to work out.
Yeah.
So now it's X. So LDA hash lower part of XPOS. Store that in there, and then the higher part of XPOS.
I think John's gone into C++ mode.
Who?
Your OR is just one bar in it in kick.
Oh. Yeah. I have too many languages going in my head at the moment.
Well, no, I did it when I was working earlier, and it's like, what's it playing at?
Yeah. The double bar is a logical OR. Basically, it comes back true or false, not a single. Right. So that's XPOS. So YPOS is the same. So now LDA hash. We're not setting any collision mask, so Z depth or it with. Oh, we're not doing the flips either, so let's just store that. And then LDA hash. Right, here we go. Oh, sod off. Kick. Right, so height, width. Right, so height, or it with width, or it with palette offset. Right, so that should set up the sprite.
It should put a sprite somewhere on the screen, yeah. If we've done all of maths right.
Okay, so
I think it took me about 17 attempts to get it for a picture on the screen.
right, let's. Oh, what did I call it? Set up sprite in Vera. Right, set up sprite in Vera. Alt bracket. Oh, why don't you see it?
Because Kick's a nuisance.
I think Kick's crashed. To be honest, I think Kick's crashed because that's what that error message was. Invalid number of arguments. Of course, because you haven't told me. Right, sprite 0. Sprite address, which is that, comma, mode. So let's go to the constants, grab the mode, which is that one. What's next? X position, Y position. So that will do for the moment. Z depth. So right, Z depth. Right. So sprite between background and layer 0. So what's layer 0?
Layer 0 is the screen that we're not using. Layer 1 is the screen that we are using, your text screen.
So if
Basically,
we,
if you want to see it, it needs to be after layer 1.
So right. So we can't use between background and layer 0. We can't use between layer 0 and layer 1. So it's got to be in front of layer 1, yeah?
Yeah, because there's no transparency on the screen as we've got it at the moment.
Right, okay. So Z, what's next? Height, width. So we're talking 16, aren't we? So 16, that one. 16, that one. And we'll use palette index 0 because that should be the default, hopefully. Right. We got one on the screen.
Yeah, that's it. Ship it. Let's go.
Oh, God dear.
It takes a lot of doing to get there in the first place, but once you've got it, John, it gets a lot easier.
Yeah. Oh, I tell you.
I don't know if you looked at my sprite engine, the sprite array that I've built. I've put quite a lot of description in there that hopefully helps understand where bits and pieces of what bits and pieces are for.
Yeah. Oh, there's me.
My atrocious attempt at doing a 32 by 32.
There's me.
Right. I think there's 10 frames to that as well. And you can I've done, if you look at it, there's quite a lot of comments on how bits of the array are flagged to do things.
Yeah, I haven't looked at it
Yeah,
yet.
no. Just basically, you can set independent speed and steps for X and Y. You can set independent timings for the frame rotations and the number of frames, whether it goes from 0 to max frames and then back to 0, or reverse and then goes backwards and forwards. Hopefully it's going to be quite good when it's done.
Right. So we've got a macro to set up the sprite. So we need another macro right now to affect its position, yeah? Because that's going to be the most common.
Yes.
That's going to be the most common thing that anybody will want to do. So this one can be move sprite in Vera. There we go.
That's right. I focused on the first things were moving X and Y around and changing the sprite address so you can animate it.
Yeah, but that was going to be another macro. So
Oh yeah, no. Well, they're the first two things that I think you need.
Yeah.
Move it and animate it.
Yeah. So we've just got the 3 now, so we should be able to. We can get rid of sprite address now because we don't need it. We need the X and Y. We get rid of the Z. Right. Let's get this sprite moving. Right. So we've got it set up. So we need a variable, don't we? So xpos dot, we'll just do a byte for the moment. Right. So store 0 in xpos. Okay. 0 in xpos. 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 0 Right. So we should see the sprite momentarily go on the screen because we set 256, 256. Right. Right. Increase XPOS. Oh, that's gonna be a problem. Same thing again.
I think you're better off doing that as a subroutine rather than a macro so you can pass it.
Yeah. Let's go back to the macro. So X address, Y pos address. Right. So load X pos address. Load X pos address +1. Y pos address. That'll sort it. So I've just converted that to a word. Y.
You didn't take the select low high out of your Y.
Yeah, yeah. Also, what I normally do is put the hash signs in, like, and forget to take them out.
I forget to put them in.
You forget to put them in. Right.
I spent ages swearing at me thing. Why isn't it going through all the sprites? And I forgot to put hash in front of it.
Right. So we're going to load 01 and store it in Y pos +1. So that's 256. And we're going to increment XPOS. Right, so we should be able to do that macro now. So move sprite number, which is 0, XPOS, YPOS. Wait, jump loop. Okay, that'll be a super fast sprite running across the screen. Oh,
I know what you did wrong.
all right, let me figure it out then.
You're not the first to do it. Can I be handy and tell you to use branch instead of jump? Makes no difference.
Okay. Well, I don't see anything wrong there. So
There is nothing wrong there.
So
There's a problem in your macro.
So it's in here, right? Oh. Yeah, I think I see what I think I see. I
didn't know specifically, but I knew from what I saw on the screen what you'd done wrong.
Right. No.
No. You're on the right lines, but you've changed the wrong thing.
Oh. What is going on?
What the hell have you done there?
Oh no. It's not redoing. What? What have I done there? Oh well, never mind.
You can just copy it first few lines from other macro.
Yeah. I have no idea what keys I was pressing then. Ugh.
That should do it.
Yeah. Oh. Oh, you're joking me. They're there. Oh, I screwed this up, right? Proper.
The macro's lost something.
Definitely in the macro, isn't it? 209. Oh. It's missed its curly bracket. There we go. There we go.
That would be when it deleted everything. Yay!
There we go. Right. So, to make it go all the way across, is we LDA xpos what xpos plus 1 because you said the 9th bit was the sign, didn't you?
Yeah. You'll end up off the other end of the I mean, you're going to go off the screen anyway at that.
Yeah,
Oh,
but it should
no, you
come.
won't.
But it should come back round, yeah. Because I'm ending it with
Yes.
1.
It's there's 10 bits because the 10th bit 10 is bit 9, the 10th bit. That will go almost to the end of the screen. Because
Right.
the screen's 640 and you're only going to 512.
There. Oh. Is it work like on the C64 using the 9th bit? It's very similar, but it's 2 bits instead of 1. So if I and that with then 3.
Yep.
That's going to go off the screen for a bit and then come back, yeah?
Yeah, and then start again. Because the visible screen's 640, but you actually got 120.
Yeah.
128 times 8, however many bytes it is. Yeah, pixels.
Yeah, so it's doing 1024, isn't it? It's going up to 1024.
Yeah.
So we're losing what, through 300 pixels off the end of the screen.
Yeah, and then if you go off the other way, you've got another 1,000 that way.
Have we? Oh, right, in the negative area.
Yep.
Right. So, okay. So let's. So we need now a sprite to change the memory address, don't we? We need a macro to change the memory address so you can do framing. Oh God! It's broken again, look. Broken again. Just behave. Just because the macro's got the same thing. Right, so set sprite address in Vera. So sprite number, that's all we need. Don't need anything else. So we need all that, and then we need all that, and then we get rid of all that. And we don't need... Oh. That is okay, need the mode in there. Because if we just store the address, that'll set the mode back to 0 if we was using... If we're using...
Yeah, but your mode's... well, it's only a matter if you use 256 bytes, colour sprites, yeah.
Yeah. So we'll better leave that in there. Right, so... if we're going to animate this... oh, let's do it simple first. Let's do it simple. So, frame. Right. We move it. Then we will ink frame I'll do the add here. I'll do the add here. ADC1 and it with 1. Store it in frame. Right. So, branch if equal to bypass. Right. So we need... not that. Yes, we do. We need that. Right. so if it's an odd frame, sprite number's 0. The sprite address, we have got here somewhere there, that. And 16 by 16 is 32. It's 32, isn't it?
You've got a constant for it.
Yes, we do. Yes, we do. Right, mode is going to be the same as that.
Yeah, but it won't work there using that constant, because you were right. You need to add 32, not. But sprite memory address is the full Vera address. Your constant is working on the shifted address, so you're better off using 32.
Yeah, we'll do 32. So that should change it. Then it goes right. So here is raster. So jump raster, and then if it's equal, then we don't add 32. Right, so that is going to be a very speedy alien going across the screen. And in fact, we're wrong. We're halfway through it, aren't we?
Oh. Yeah, because you don't add 32. Oh, God.
No, it's 128. It's not 32.
128, yeah. It's that number there.
Yeah.
Confused by the 4, because that's in the Vera space.
There we go. There we go. Go for it, buddy. Right. So, now that's not what I want. So I want to right, I'm going to end it with I'm going to end it with that, and then store it back, but then I'm going to end it with that. Right, that should do it. Right, that should slow it down. There we go. There we go. Go, little fella. You can do it.
Hello, John here. Thank you for following. Hope you enjoy the stream.
Oh, who's joined? Who's joined? Who's joined? Paradox, welcome. Say hello. We don't bite. We don't bite. Right, so we've got a macro to set up the sprite. We've got a macro to move it. Now we've got a macro to set its frame. Right, so you've got another couple of sprites in here, haven't you? So
yeah, there's 8 in that.
So if I do 256, and then that's 256. And then this will be 256 plus 128. 3. Oh, my brain's gone.
304.
30 what? 384.
384.
384. Right, that should be your other. That should be another.
Yeah, 384.
Oh no. That's still the same sprite.
Yeah, no, take that 256 off the copy. Leave that as it is.
Oh. It's here, isn't it? It's that.
Is that puts all H? No, that's fine.
Yeah, it's the.
Oh yeah, that one wants
Yeah.
to be plus 256.
Yeah.
Yeah.
That's what. Hey!
Because you've still loaded all 8 sprites into memory. You're just picking which frames you're using.
Yeah. So
now you can put a sprite on the screen and move it and animate it. You can turn Myriad into sprite based, John.
yeah, yeah, yeah.
The collision bit will take some doing because that collision mask is horrible.
Yeah, but I mean, we're one step at a time.
Yep. Oh no, it's like we're working out. Oh, I spent hours on that thing just to get 5 sprites moving around the screen at different speeds and everything.
Because I was just wondering what to do to try and put this into reality. I mean, Space Invaders is a simple game to do, isn't it? But you'd need an array. You'd need your sprite engine to work that out.
Yeah, and it's not got everything in it yet. It's still working. Although you're welcome to take it and do whatever you want with it, John. And if you're not sure how any bit of it's behaving, then I'm here.
Well, yeah. I mean, I haven't looked at it yet, but the fact that we've got an engine that could run all 128 sprites.
In theory, I've not had. Well, I say I've not had 128 on. I've turned all 128 sprites on for the engine to look at, and excuse me. Now I've moved the code around, so the interrupt actually just does a small part of it, and then you deal with all the moving and animation outside of the interrupt loop. So you can take your time. I think it's very quick during the interrupt part, so you've got a lot of time to do everything else.
Yeah. So, we've got a sprite wandering across the screen. So that's 512 then. 512. I can't be bothered to work it out. Hey, look, there's another one. Right, so we've worked out how. Have I still got that open? Yes, I have. So we've worked out how to use the sprite attribute table within Vera. We've created a macro to set the sprite up. We've created a macro that allows us to change the position of a sprite. And we've set a macro that allows us to change the frame of the sprite. Now, the framing I'm a bit concerned about because we was talking about losing the 5 bits.
Yeah, but your macro, you're dealing with the full address. If you just read what's in there or have what's stored in there stored somewhere, you can just add 1 to move one. Well, add 4 to move 1 frame along in a 16 by 16.
Yeah. So
in theory, you could change it to load what's in that byte 0, add 4, and then write it back, or subtract 4 and write it back to alternation.
Yeah. Well, the fact that we've got a sprite on the screen and now we understand this sprite table, what it's doing, and we've got some macros that allows it to work. I think that's a step in the right direction.
Oh yeah, definitely.
So we need.
It's because yours is quite rightly so, John, instructional. This is so people learn how it works, and the way you've done it gives an in-depth look at how everything behaves, which is spot on.
Yeah.
On my code, and they'll go, "Hey, what's that?"
Well, like I say, I haven't looked at it yet, so I want to get the sprite editor working first.
I'll get that working because I want more sprites, and I'm useless graphics anyway. But
yeah, so I'd rather work on the sprite editor. But what I think we will do is we will. What's too many things to do at the same time? Because I wanted to do the multicolored sprites on the Myriad as well.
Need the sprite editor for that to generate tile.
Yeah, I need to get that sprite editor done. Maybe the next stream is going to be a TypeScript stream. Just to get it done. Right, okay. So, the collisions, I'll have to read up about the collisions.
It's quite dumb because it's basically you set a mask on a sprite number and a mask on another sprite, and it hands those 4 bits together. So literally you can tell if 2 sprites have collided or not. But like if the mask for all your bad guys is say 3, bottom 2 bits, the way I was thinking it, you've got 4 bits, and if you set, for example, bits 0 and 1 to a 1 on all your bad guys, and bits 1 to a 1, or simplify it, bit 0 to a 1 on your bullet, whenever your bullet and any sprite with that mask with bit 0 set collide, it will trigger an interrupt, but it doesn't tell you which sprites hit it. If you've got 10 sprites all with the same mask, and you've only got 4 bits to work with, and it's not a number, it's just 4 bits.
Right.
So the way I thought is, right, I can tell, by doing that, we can tell if, like, a bad guy and a bullet have collided, a bad guy and your... Checking Myriad as a working principle. Bad guy, bullet, spaceship. Yeah? So you've got 4 different things. And if you work the masks out right, you can tell whether a bullet's hit a bad guy, bad guy's hit your spaceship, or an alien bullet has hit your spaceship with a bit of jiggling around. I think that's about as much as you can do.
Right.
So with the spaceship you're fine. With the bullet you've then got to work out which sprite you've actually hit based on coordinates, but you don't need to check until it's actually triggered to say it's hit something.
Yeah.
So it removes a bit of the check because you don't have to look if it's hit, it tells you. It's just working out what it's hit is another matter.
Yeah. Alright then. Okay guys. Well, hang on. There was the X16 Loo script linked to in the Discord for Sprite, which should allow you to export files. Yes, mate. But like I say, I've been trying. If we can do this Sprite, mate, and get that out there, then at least we should have a quicker way of creating sprites. But yeah. All right then. So. I think we'll call it there because, like I say, it was a bit slow getting going, wasn't it? Trying to understand what was going on. But
there's a lot to it. You go, oh, it's simple, it's just a sprite, but there's quite a lot to it.
Yeah. So I will say, okay, guys. Well, thanks for joining me. I'll think of what I'm going to be doing on Wednesday.
Sprite editor.
Well, we might do a TypeScript because I don't know TypeScript and I'm struggling a little bit. Maybe some people out there got TypeScript experience and be able to help me. All right then. Right then. Well, thank you very much, guys, for joining me, and I will see you on Wednesday. Oh my God, a short stream. 3 hours. Wow, I'll be able to go to bed early. All right, guys.
It's good, that.
All right then. Thanks a lot for joining me, Saucy. Thank you, everybody who was on stream, and I will see you later on. Take care. Bye. I'd like to thank all the patrons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.